record. So we're now recording and we're going to get started. Okay, so what I've decided to do today, because everyone's having so many questions, is we're going to do one more review, really looking at the problems I'm seeing on the homework and the assignments. A lot of the problems are still from chapters 3, a little bit on chapter 1, although not much, chapters 3 and chapters 4, and I want to clear that up because once we get in chapter 5, it's a whole different ball of wax because that is mostly economics. So we get into some very thorny issues which upsets people on why economists think that we should be here instead of there, and it's a whole different type of discussion, but it's not so much Excel files. So I want to handle these Excel file problems, then we'll go to chapter 5, and then my next lecture after that, I'm going to give a demonstration PowerPoint on what an actual presentation of a CBA would look like. Because what you're doing now is these little micro parts of them, and I want you to kind of understand how to structure a presentation. And it will also help you with your final projects, because after chapter 5, the undergraduates are basically done with the class, except doing their homework. So I'll be working with them individually, but the graduate students, of course, have more chapters, which frankly are the most interesting chapters because we're past all this basic stuff. And we're really talking about things like, what do we do about projects that benefit the poor but don't really have great NPVs? How do we convince people to do them anyway? How do we deal with things like distributional issues, which was really interesting about the aquarium fishery industry. We got totally all secondary data and pointed out that, 20 people in this industry make all this money, but the cost is spread over so many people and is so horrendous of taking these fish out of the reef. So that's really what we looked at, and we did a lot of stakeholder distribution assessments, and probably the most unusual assessment I've ever seen of stakeholder analysis of how it actually affects people within the community. So distributional issues are something that you can do with CBA that you rarely see. So it's very interesting if you're interested in that. For those of you interested in social justice, these sorts of things can be very powerful, and you can run off secondary data. If you do the presentation right, it's just as powerful. So these lit review stuffs are nice because you don't have to collect primary data. Primary data is very expensive. So that article is also very helpful. So we're going to get started. So first thing we're going to do a share screen. We're going to cut to an Excel file. Of course, here I am, always trying to find them. So we're going to share a Book 7 Excel file. I'm going to rename it when I put it up, and I'm going to move you guys to the side. I'm going to blow it up. So I want to talk about some details that people are not quite getting. So the first thing is this idea that we're going to do investment that don't have equal time periods. So we notice here that I've got one investment that only goes for 3 years and one that goes for 4. And this is a common thing that you see, as I've suggested, in many projects and not just business projects. When you're doing government projects, again, these lengths of time will start to affect it. I've seen things where we're investing in dams. I see things where we're looking at roads, schools. A lot of infrastructure things will have different timeframes associated with it. So sometimes you need to look at these situations where you have investment with different time periods. So this is what we've got here. So I want to demonstrate this thing that they're calling the terminal value, which seems to confuse everybody. So why we're looking at the terminal value is it lets us compare investments that have different timeframes attached to them, because it will take account of the fact that, say, this first investment that stops after 3 years actually is something we can extend longer. Another type of thing we'll see is something where we'll have an investment which has a bunch of zeros and it's all at the end. So sometimes we have a hard time with this kind of stuff. So sometimes terminal values help us there. So let me just type in a different one we can try. Of course, I make these numbers up, so heaven knows what the NPVs and IRRs will actually come out to be. So here we have these options. So if you're going to terminal values, you're literally moving everything here to that 4th year. And you can do this with a formula on your computer. And as long as you enter these years as I have them, some of you are putting year 0, year 1. Once I get going, you notice I've stopped doing that. And the reason is because then you can click on those numbers and enter them into the formula without having to deal with it. And it's very useful when you're doing inflation of cash flows and when you're doing terminal values of cash flows. So all we're going to do is trying to get everything from all these things in year 4, and then we can actually calculate the NPVs again. And that's what these terminal value problems are asking you to do. So we're going to copy this row down, or this column. I'm going to put it down. Ooh, I'm going to have to go there. Okay. So we're now going to get a terminal value, and that means for the first one, it's always going to go to year 4. So how am I going to do that? Well, I'm going to do a sum. So equals. So the first year, right, is 0. Right? So we have a 0. And then we add this 25,000 going to year 4. So you have that 20. So you don't hard type it, but you go here, 25,000, right? And you're multiplying that by 1 plus the reinvestment rate, which I have at 6%. So I put that in, and then I raise it, right, to 1, because I'm only putting it forward 1 year, from 3 to 4. So you notice I can just hit this 1, and then I can do the next term, which is this second year. So I've got that 20,000 is going to be multiplied, the 1 plus the reinvestment rate. And that's going to be for 2 years. And then you notice how these colored boxes let you keep track of what the heck you're doing, because it's really hard to get in the swing when you forget what you're doing. And I sometimes get so wound up in these formulas that I do forget, and I can look and see where I am. 1 plus the reinvestment rate again. And that's going to be raised to the power of 3 because you're discounting it for 3 years. So what is in fact the terminal value of this investment? $66,837.24. So what does that actually mean? That means when this money comes in, I don't have another project poised and ready to go. So I put it in my parking place, which usually pays less than my usual projects, because I'm just trying to get enough money to start my next project. Because, you know, 15,000 maybe not enough, 20,000 maybe not enough. Maybe I need to have a sinking fund. So we can do the same thing here. And what you're having with your homeworks is you're not quite understanding what we're trying to do with this. So this is why we're going over it. So there's that one. Then we're going to take that one, multiply it, the reinvestment rate, and it's only going to compound for 1 year. And then I will post this so you can see what it looks like, because I know it's hard to remember all these little tricks that I do. But if you get used to using these formulas, someone was complaining that it's just too hard. And what I'm suggesting, that if you really get these formula loading strategies down, where you can load these things without having to do all that, it's very useful. Does that make sense? Okay. Oh, what have we done? Oh, right here, I didn't put my multiply sign. This is a common error for me. How do I know I made an error? We come up with a funny sign in our cell. We don't have an answer. So as you look at this, the question you may be thinking is, oh, is this $30,000 investment better than the $40,000 investment? Do we actually know right at the moment? We don't know. We don't know because we would have to come up with our NPV. So now you can do an NPV on this one and compare it head on with an NPV on that one. So some of you are not doing that. You're somehow just looking at this terminal value, or some of you are moving that $30,000 to year 4, which you could do, but generally what we do is an NPV. So let's do the NPVs and see what they look like. So again, though, you're wanting a 12% discount rate. So there's our rate. Okay. Now, what problem are we going to have if we try to discount this like it is? And some of you are still doing that. We don't have zeros in here. So it's going to read those as missing. It's going to think that 79,000 or that 66,000 is in year 1 and not year 4. So I've got to get out of this thing, go back, and put in these zeros, right? Because I move that money through time to year 4, and it's not in year 1. Right? So I need those. And some of you are forgetting them. So NPV one more time. Again, I'm discounting, so you use the 12%. I just had someone hand something in that did not use the 12%. You take your range. And lastly, we must remember to add in our initial investment right there. There we have it. Oh, why is it in a percentage? Let's get it in currency. So the NPV of this investment is $12,000, $12,476.27. Not a bad deal. At a 12% discount rate, this is looking pretty attractive to this woman. So I'm thinking, that looks good. Let's see what the next one looks like. Same thing now. You've got to remember to do the same stuff. Use the appropriate discount rate. Again, here's our values, our net benefit stream. Then we add back in our initial investment. Oh, why are we all at these percentages? Okay, so initially, could we really tell which of those was the better investment? Not exactly, because you really need to account for these costs and do that discounting. So in fact, both of these are pretty good investment, but the first one looks a little bit better. But let's try an IRR. It says actually everybody seems to be doing pretty good with their IRRs. On the whole, it's NPV that's driving everybody to distraction. So again, all we need to do is put in our range, highlight it, hit return. Oh, what did we do?
I think you forgot year 0.
No, I don't put in you. Oh, yes, I do. That's what I did. You're so right. See, this is the type of stuff that drives everybody crazy. So 22.17%, that's a killer return. And this one's not bad either. How do I know that? Because I've got a positive NPV. So still, this $30,000 investment looks pretty good. So that's the problems I'm seeing on this reinvestment rate. No one's really understanding what you're doing. I know it sounds strange, but in fact, this is very common, that you don't have enough after 2 or 3 years to invest in your next project. Particularly if you're buying houses, they're kind of pricey, right? And then you buy one, I don't know, is it just me? Then you have to put money into them because they were neglected. So I always end up the down, 25% down, and then I'm still another bunch of money to deal with electrical problems and all these things. So, but you see, that's what we're doing. And so when you do the reinvestment rate, you're moving it this way, the last year, and then you're discounting using your desired opportunity cost, which in this case is 12%. Does anyone have questions? I've just noticed everything I've graded has been, almost everything somebody has been confused. And it usually has to do with putting the zeros, or they somehow want to move the $30,000 over here, which you could do. That's not a bad idea. But again, then you have future dollars in year 4. Why are we talking about year 4? Let's get it back into today's dollars. That's always an easier discussion to make a decision about when you're spending $30,000. I'm not going to spend $30,000 on something that you're hypothesizing in year 4. It's just not what I do. So I'm kind of into this, get it back in year 0, because that's how investors think. So that's the problems I'm seeing there. Now let's go over this payback period. Because again, as I talked about in the last lecture, back in the day, because none of us had calculators, I mean, back in the 60s, payback was where it's at. And you will still hear people mention it. And the reason why they do is because it's very simple. So you look at this first one. So you're investing $30,000. The first year you get back 15. So you're still 15 down. By the next year, in the second year, you have paid back this entire investment and still have $5,000 to spare. But I must caution you that you're ignoring the time value of money. You're ignoring the cost of waiting when you use this technique. But it's a very good back of the envelope for businesses, because businesses hate to wait. I'm going to tell you, if you're dealing with people that want to get paid, they want their money as soon as they're done with the job. This is one of the first things they all talk about. Pay me. I did the work, I want to be paid. So in this case, the payback period for the $30,000 investment is slightly under 2 years, because you've paid back the whole $30,000 in less than 2 years. So if you have a large opportunity cost for waiting, as I just described, pay me now, I can't wait, then it does help you kind of winnow things. What it doesn't do is help us with long-term investments. If we want to be sustainable, we need more long-term investments. We can't go for the quick win every time. But I'm telling you that businesses often will go for the quick win because they have very high opportunity costs of waiting. When you're running a business and you got a payroll that's got to be paid on Friday, this is something that you must pay. You can't expect workers to sit around and when you don't give them paychecks. So you can imagine what this Corona thing has done to private businesses and how difficult this is to get around. Because then they try to go hire someone else, and because their workers quit and got another job, and it's very messy, very expensive. So this is why we use payback. Now let's try payback for the $40,000 investment. So the first year you get 10, so you're still down 30. The next year you get 15, so you're down 25. The next year you get 20. So still this thing is not paying back till that 4th year. So it's just over 4 years, because you only need 5,000 more and you get it within the first 1/6 of the year. As soon as 1/6 of the 4th year is over, you've paid back. So that's what the payback is. This is why we're discussing it. You will still hear it. Why do you hear it? You see how simple it is. When does my money get paid back to me? I spent this much. When does it come back in my hand? Pretty straightforward, pretty darn simple. Anybody has questions? I think that's on homework 4, and I'm still having people that are slightly confused. Any questions? Okay, so average rate of return. Again, average rate of return does not take into account the time value of money. So we use it because it's simple, and if you do financial analysis, so very often when I'm helping a business, when I'm looking at their balance sheets and income statements, I'm looking at, okay, what kind of rate of return did you earn this year? So we will be talking often about an average rate of return. And you will talk about it over time even, like, oh, we made 15% last year on all of our assets. And this year we earned 18%. Okay, this is a good thing to know, because you want to know how much profits your assets produce. Where did we get our assets? We bought them in a project with our year 0 money. So let's look at what that would look like for these first 2 investments. So what do? You take the average net benefit that you get here. So in this case, you say sum, then you highlight, right? Sum. So that's our sum. And then you want the average net benefit you got. But you notice this was not for 4 years. This was only for 3 years. So you're going to divide it by the number of years that are relevant. In this case, it's 3 years. So on average, you're making $20,000 a year on this thing, which I'm telling you is great. So we're not complaining about that, but we just need to know how to figure it out. So then this is your return, but we want to compare it to what was that value of that asset. Remember, I've told you that accountants are obsessed by what are your assets valued at. Is my house worth $20,000 or is my house worth $80,000? It may seem trite to you, but when I go to figure out a return on my investment, it matters. If my house is only worth $20,000, then I'm not expecting the same amount of net benefit as compared to it's worth $80,000. So these values matter, and bless those economists or those accountants. This is what accountants do for us. They keep track of these values. So this is why we love them. We want to know what we have invested so we can figure out what kind of return we can expect. You're not going to invest $80,000 and expect nothing. That's not going to work. So let's go ahead here then and then calculate what that average rated return would be. So you have this thing equals this, which is our average profit per year. And you're going to divide it by, I think this works, absolute value of this 30,000, right? Okay, they don't like that. So we're going to put a minus because that has a minus sign. We're ignoring all these negatives and positives. Otherwise, it's going to come out positive or negative, and you're going to wonder what happened. So we're making a 66% average return. It's in a decimal, but we could put it in a percentage on average for those 3 years. So that's pretty good. But remember, we're ignoring the time value of money. So it looks really great because we're ignoring that. We're acting as if this money comes all at once, right? We're not waiting. We're not caring about waiting. We are caring, but this is a normal thing. When you go to businesses, they will be talking about their annual average rate of return. This is what they should be talking about. I'm not going to invest $1 and not get more profits back. So this is what they're looking for. And some of you are having issues because you didn't really know what was going on. So for this one, again, what's our average rate of return? We take the sum. Here we go. Right, and then we're going to divide by the number of years. So this one, again, consistent with all of our other measures, has a lower average rate of return. And so if we were to put that here, you just take that number, divide it by our initial investment, and we will end up with a percentage. But we need to put the minus sign, otherwise it's going to be minus, and you'll be like, what? So there we have it. Once again, proving to ourselves that that $30,000 investment is, wow, good job. So that's how you do the average rate of return. I think it's question 3, homework 4. That's how you do it. That's how you do payback. And the rest of it is stuff you've already done. IRRs, terminal values. And again, for 4, if 4 was already there, then we don't really need to worry so much about that one. If there was 0, 0, 0, and everything was in year 4, but this 3-year one, we really need to move everything to year 4 using that reinvestment rate, which is what you get when you park your cash somewhere and let it just earn interest, because it's not enough money to do a new project yet. I gotta wait. This house is expensive. I gotta save the down. I need more bucks. Let me park it. This is what I'm earning. There we have it. Real estate, for example, is lumpy, and so are many things, because equipment is getting very expensive. Infrastructure is incredibly expensive. Roads, buildings, outrageous. So It's very difficult to save large chunks of money quickly unless you're a super big business. And this is why our small businesses need us to help them do these things. Does anyone have questions?
I got a question. This is Jordan. So, homework number 2,
Yes.
or sorry, not homework. Homework number 4, problem number 2, asks us to calculate a modified rate of return. What's meant by that? Is that based off the terminal value?
Yeah, that's an IRR.
Determine the modified rate of return and the modified IRR.
Yeah, so you modify the IRR by moving everything into that terminal value, right? So you see, I've changed the look of the problem. I no longer have this. I now have all the money at the end.
Yeah.
So there's going to be a new IRR.
Okay. And that new IRR is the same as the modified rate of return?
Yes. Sorry.
Okay, no worries.
The reason I said that is I think there's actually a function called the modified IRR that you can just hit it again and you don't have to, you know what I'm saying?
Okay.
I think there's a formula, but I don't want to confuse everybody. It's just a new IRR because sometimes when you do these things, I give you different discount rates, but the IRR always stays the same. When I give you a different discount rate, the IRR never changes, right? On your first homework, I gave you 6% and 8%, but the IRR stayed the same. On homework number 2, I think there was a bunch of IRRs. They all stayed the same. But in this one, the IRR will change because you're physically investing money at a different rate than you were using to discount. So the IRR will have to be recalculated when you're using TVs. Does that make sense?
Yep, thank you.
So sorry about that. It's just an unfamiliar word in the homework question, but it's just a modified IRR. And when you actually do the pull down menu on the functions on Excel, I think they call it an MIRR. So it's just the new IRR plugging in a different set of numbers with a TV instead of this other string that we had before. Any more questions? Answers?
I have a question.
Yes, ma'am.
On assignment 4, questions 2 and 3, I'm having a hard time setting those up. Question 3, I'm having a harder time with, but both of those, I'm not quite sure if I'm setting them up right.
Okay, so I think on yours, you didn't have zeros on one of them.
No, the not homework 4, assignment 4.
Oh, assignment 4. Let me look. Let me cheat and see what that is. Of course, I will also see the answer, but hopefully.
I don't know if question 3 was assigned for homework or for assignment 4.
No. Question 2, question 4, question 5, and question 6.
Oh, I've been doing all the questions. Oh my gosh.
I was doing that too.
Well, someone is being quite the worker bee.
No.
If you do that, I'll usually get back to you and say, no, that wasn't assigned, but sometimes I'll grade them.
I haven't uploaded any of my assignments yet, but so far 1 through 3, I've done all the questions that were in there somehow.
Think of how smart you're going to be.
No. Okay.
But I think all the other questions, like 4 and 5, we went over last week, right?
Okay, so 2 is not on there then? We don't need to know 2 either?
2, yes. 2 is, do you not understand 2? Do you want to go over that?
I'm just having a hard time. Yeah, that one I'm just not sure if I have it.
This is kind of a trick question in some ways for you. So you have a dam that's been built and it cost $100 million to build. And do we care about that?
Yeah, maybe.
We spent that long ago. Listen, we have something in economics called sunk costs. If I spent $100 million 10 years ago, doesn't mean squat today. I'm talking about the future. I'm not talking about yesterday here. So whatever that dam cost to build is fine, but we're talking about doing an addition to the dam. I want to talk about that addition. I don't want to talk about what we did however many years ago. Does that make sense?
Yeah.
Trick number one of this problem, because everybody obsesses about this 10 million.
Yep.
But it does produce 15 million kilos of sugar at $1 per kilo. So it generates 15 million in sugar revenue, right? And they're saying that you can raise it at a cost of 8 million. So what is the cost of this project? Let me see, we can raise it at a cost of 10 million. So what's the cost of the project, Alexis?
If you're raising it to a cost of 2 million?
No,
So
we're raising the dam at a cost of 8 million. So that if we're gonna do it, if we're gonna build a bigger dam, what's the cost of building the bigger dam? 8 million. They
okay.
just said that. The height of the dam can be raised as a cost of 8 million.
I think I overthink these
You
things.
way overthink these
Word
things.
problems get me.
8 million is what that baby costs us, and that's what we're thinking about spending. So that's the cost in year zero, 8 million.
Oh, right. Okay. So it says it right there. Raised at a cost of 8 million.
Yes.
Okay.
And then it says if we did that, instead of getting 15 million kilos of sugar, we would get 15.5. So what's the benefit of raising that dam? 500,000 more kilos of sugar. Right? Forever.
Okay.
Forever. So we got to figure out, what is that sugar worth? 500,000 kilos, and it says, oh, $1 a kilo. So we're going to get 500,000 more a year forever if we spend 8 million to change the height of that dam. Does that seems pretty straightforward to me. Does it to you?
Yeah, I guess how am I incorporating the $1 per kilo in?
Okay, we got 0.5 million more extra kilos of sugar from raising the dam. It's what it says. It used to do 15 million, and now it would do, if we raise it, 15.5. So 0.5 million more kilos, right?
Right.
And it says that the world price is $1 per kilo.
So I'm just multiplying that.
Yes, good economists are really good at just taking numbers and multiplying. You tell me it's that, I'm multiplying. That's how we are. We're terrible like that. Everybody wonders what I do. I'm like, oh, I just call someone up and say, how much does this cost? How much would I need? Okay, great, thank you, bye. Write it down and multiply. This is what I do. Now, the trick here is what? The trick is that this goes on forever. It goes on forever. So if you read my FAQs and all my other little subtle hints that I throw at you, on page 31, you will find a very simple formula for what you do if stuff goes on forever.
Okay.
And you basically just divide by the discount rate, right? So you've got an annual benefit of 0.5 million. You've got a cost of 8 million. So what's the NPV? That's all you got to figure out. So you have the annual benefit, you have the cost in year zero, and you have a discount rate for 10%. So if you look on page 31, it's just a simple divide. It's very easy.
That helped a lot. Thank you.
And you look at the FAQ, it'll also tell you the same thing. And I want to point out here that it would seem to me that spending 8 million and getting back $500,000 a year sounds like it's going to be a winner investment, right? Just on the face of it, doesn't it sound good? $500,000 a year forever. Doesn't that sound like a lot of money?
It does.
I know it does, but when you work out this problem, you're going to find this is a loser investment. So this is what I keep telling you. Large initial sums do not pan out. When you got to wait for your money and you put out a lot in the beginning, they do not pan out. So these large infrastructure investments and things like this, very difficult to pay back. And you will, if you do not get a negative number for number 2, you're doing something wrong. because you
Okay.
got to get a present value of that 0.5 million a year, and then you got to subtract year zero, right? Year zero is 8 minus 8 million. What's the present value of $1 million a year forever? 0.5 divided by the interest rate, which is a pretty easy division. Anyone has more questions on that one? I'm just telling you, if it's not a negative number, you've done something wrong, and it should take you all of 5 minutes to look at the formula and do this. Because if you look at this word problem, it's very clear. It's just when you're not used to word problems, you kind of get confused. Any more questions on that? I'm going to post this, and I'm going to tell you page 31 for problem 2. I've had one person turn it in and did a great job on it, who shall remain nameless, so I won't name this person. So let's stop sharing, and I want to go back to one more thing that Alexis had a question on earlier today, and I want to explain it. Okay, the depreciation example. So let's stop the share. Let's go back to the PowerPoint. This is always what happens to me. My screens are so, I need a bigger top. Okay, so we're going to go back to this PowerPoint. And let's go to the screen view. So again, let's look at this depreciation example. And we go through this whole thing. All we're doing is our annual cash savings. This is to calculate the annual net benefit after you buy the machine. What is this minus $1,000, or how much was the machine? The machine cost $10,000. That is not tax deductible. That is a purchase of an asset. The only thing that's tax deductible is depreciation, and that has to occur after year zero. And that's going to have an impact on the cash flow for that business every year. In this case, for I think 5 years. So all this is here to do is give you, and conveniently, I'm very nice, so we have straight line depreciation. It's the same number every year for 5 years. So when you fill out your cash flow spreadsheet, year zero is the cost of the machine. And this number, this bottom number, is the annual net cash benefit, because in this case, we're looking at a benefit, not a cost. In the problem, I think you were assigned, we were more like this, where you were looking at a cost. Does that answer your question, Alexis?
Yeah, that helps. And actually, when you were working out the first example that you did, I saw how that factors in. So.
So again, don't get confused. The only reason we're doing this is because remember on chapter 3 how concerned we are with how much money these businesses are making. We want to know their net profits, and depreciation is a tax deductible expense. We have to account for it. We can't do investment analysis unless we account for these things. So that's what we're accounting for. So when you do an NPV and an IRR, it's actually real business information, because you cannot negotiate with a business if you're in a community if you don't really know what's going on. And a lot of them will want tax breaks. This is why, right? Like, no, let's not do that. Let's talk something, again, we need to be in command, because every dollar that business makes is great as long as they stay in the community. But if they're an outsider and they come in, those profits go away. And the profit of a business is defined as the benefits minus the cost minus the taxes. Unfortunately, you can't escape doesn't taxes. So that's where we are.
Mind if I move your car?
No. Just take this little purse with you and hit power and it's going to go.
Sweet.
You got to have the key in the car. I mean, the key in the purse. Sorry, guys. We've got a lot of contractors today. Anyone has more questions? Because that's about done, and that really covers all the problems. And then on the next lecture, we'll have the econ review, and then we will also have a presentation of a CBA by the end of the week, and then we'll launch into the graduate student stuff after that. Any questions? Okay, so I'm going to post all this. I'm going to stop the recording.